Hi students, up to here we discussed context model, interaction model, structural model. In this class, we are going to discuss behavioral models. Behavioral models are models of the dynamic behavior of the system as it is executing. Means what is the dynamic behavior of the system while it is executing, we are going to discuss in behavioral model. Okay, and they show what happens or what is supposed to happen when a system responds to a stimulus from its environment. Stimulus may be of two kinds. Okay, how this stimuli, there are two kinds. One is data, another one is event. Okay, data, some data arrives that has to be processed by the system. Means some data will be given to system that should be executed by the system. Okay, that is data. What is the event? Some event happens that triggers system processing. Event may have associated data, but it is not always the case. Means some event happens that trigger system processing. Means it's going to lead for the system processing, that is event. Event may have associated data, but that is not always the case. Means some event should be happen, means that going to associate it with the data, that is not always the case. ಯಾವಾಗಲೂ ಆ ಥರ ಚಾನ್ಸಸ್ ಇಲ್ಲ. ಮೀನ್ಸ್ 50-50. ಓಕೆ, ಮೀನ್ಸ್ event with the associated data, there is a 50-50 chances. Okay, many business systems are data processing systems that are primarily driven by the data. Okay, they are controlled by data input to the system with relatively little external event processing. Okay, for this slide I am going to explain what is mean by event and what is mean by data in detail. There you are going to understand easily. Okay, their processing involves a sequence of action on the data, the generation of an output. Means we should give the input, we are going to get the output. Okay, in that, in between giving the output, giving the input and getting the output, some process is happening. How this is going to happen, we are going to discuss in further slides. For example, phone billing system will accept information about the call made by the customer, calculate the cost of this calls, generate a bill to send to a customer. Means your billing system, how it going to work means, phone billing system will going to accept the information about the call made by the customer. First they are going to check what are the, who made the call, means who are the customer. First it's going to see, then it's going to calculate the cost of the call and generate a bill to send to the customer. Okay, this is how it's going to work. Next, data driven modeling. Data driven modeling show the sequence of action involved in processing input data, generating a associate output. Means what is data driven means, data driven modeling shows a sequence of action involving in processing input data and generating associate output. Means we are going to give the input and sequence of process will be happen to the input data and it going to get the associated related output we are going to get. They are particularly useful during the analysis of requirement as they can be used to show end-to-end processing in the system. When this data-driven modeling is important means when we are going to get end-to-end processing in the system, there we are going to useful. That is, they show the entire sequence of action that take place from an input being processed to corresponding output. Means input to output, what the process is taken on or what process is going on, we can easily understand. Okay, which is the system response. Data flow diagram is a way of instructing the processing steps in the system. Means data flow diagram is a way of illustrating the process steps in the system. Okay, the data flow models are useful because tracking and documenting how the data associated with a particular process move through the system help analysis and designer understand what is going on. Means using this data flow models are useful because tracking and document for the analyst and designer to understand what is going on. Means there is a tracking is there, document is there, means obviously the analyst and designer can understand what is going on in the system. Okay, the UML does not support data flow diagram. Means UML, Unified Modeling Language, does not support data flow diagram. Means it is not going to support data flow diagram. UML does not support data flow diagram. The reason for this is that DFDS means data flow diagram focus on system function, do not recognize system object. Why this UML does not support data flow diagram means because the data flow diagram is going to focus on the system functions. Okay, do not recognize the system objects. Okay, however, because data driven system are so common in the business, so UML 2.0 introduce the activity diagram which are similar to data flow diagram. So next question, UML 2.0 introduce the activity diagram. Means data driven systems are common in this data flow diagram is not supported by the UML. So to alternative for the data flow diagram, UML 2.0 introduce the activity diagram because it is similar to data flow diagram. Okay, you can see that there are two diagrams here. First diagram represent the order processing. Okay, blood sugar sensor means it going to sense what is the blood sugar level and get sensor value, sensor data, compute sugar level, blood sugar level, calculate insulin delivery, next insulin requirement, calculate the pump command, pump control command, control pump insulin pump. Okay, means how the insulin given to the patient, where the activities carried in the system will be explained in this flow. This is the order processing. Okay, then you can see that this is an activity model of the insulin pump operation. Okay, this is an activity model, means activity diagram is the alternative for data flow diagram. Okay, this is an example for activity model. Okay, here you can see that purchase officer fill in means it's going to give the order. If it is because they are going to get they are going to check the it is valid or not. It is valid valid is okay means update amount means ಎಷ್ಟು ಬೇಕು ಅಂತ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಆರ್ಡರ್. ಇಟ್ ಈಸ್ ವ್ಯಾಲಿಡ್ ಮೀನ್ಸ್ ಎಷ್ಟು ಕೇಳ್ತೀವೋ ಅಷ್ಟು ಇನ್ಸುಲಿನ್ ಪ್ರೊವೈಡ್ ಮಾಡಲ್ಲ ಮೀನ್ಸ್ ಸರ್ಟನ್ ಕಂಡೀಷನ್ ಇರುತ್ತೆ. ಆಮೇಲೆ ಇಷ್ಟು ಬೇಕು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಎಲ್ಲ ಸರಿ ಇದ್ದಾಗ ಮಾತ್ರ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೊವೈಡ್ ದಿ ಇನ್ಸುಲಿನ್. ಓಕೆ, ಇಟ್ ಈಸ್ ವ್ಯಾಲಿಡ್ ಮೀನ್ಸ್ ವ್ಯಾಲಿಡೇಷನ್ ಓಕೆ ಆದರೆ ನೆಕ್ಸ್ಟ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಬಜೆಟ್ ಮೀನ್ಸ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಅಮೌಂಟ್ ಶುಡ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಓಕೆನಾ. ನೆಕ್ಸ್ಟ್ ಸೇವ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಅಮೌಂಟ್ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆದಮೇಲೆ ಡೇಟಾ ಸ್ಟೋರಲ್ಲಿ ಆರ್ಡರ್ನ ಸೇವ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಆ ಸೇವ್ ಮಾಡಿದ್ದನ್ನ ನೆಕ್ಸ್ಟು ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸೆಂಡ್ ಟು supplier. Okay, means update amount means after paying amount it going to save the order. After saving, then after certain period it going save ಇರೋದು ಸೆಂಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿ ಸಪ್ಲೈಯರ್ಗೆ ಪಾಸ್ ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ ಆ್ಯಕ್ಟಿವಿಟಿ ಡಯಾಗ್ರಾಮ್. ನೆಕ್ಸ್ಟ್ ಡೇಟಾ ಡ್ರಿವನ್ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಈಸ್ ಇನ್ ದಿ ಬಿಹೇವಿಯರ್ ಓನ್ಲಿ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ event driven modeling. What is this event driven modeling? Event driven modeling show how a system responds to external and internal event. Here we clearly know that what is meant by data, what is meant by event. Okay, it is based on the assumption that a system has a finite number of state and that event may cause a transaction from one state to another state. Means for the assumption system has a finite number of state and event. Okay, finite number of state irutte, event irutte. Okay, for example a system controlling a valve may move from one state, that is value open, to state value close when a other command the simulates is received. Means ಒಂದು ಸ್ಟೇಟ್ ಇರುತ್ತೆ ಓಪನ್ ಅಂತ, ನೆಕ್ಸ್ಟು ಅದು ಕ್ಲೋಸ್ ಸ್ಟೇಟ್ಗೆ ಹೋಗಬೇಕು ಅಂದರೆ ದೇರ್ ಈಸ್ ಎ ಒನ್ ಈವೆಂಟ್ ವಿಲ್ ಬಿ ಅರ್ಕರ್. ಓಕೆ, we are going to discuss in next UML diagram. UML supports event based modeling using state diagram. Means event based modeling we are going to discuss with state diagram. State diagram shows the system status and event. What this state diagram is going to show, is going to show state and event, the case transition from one state to another. Okay, they do not show the flow of data within the system but may include additional information on the computation carried out in the each state. Okay, in UML state diagram, round rectangular represent the state system state. Means these are the states: waiting, full power, off power, set time, disabled, enabled, operation, waiting. These are the state. Okay, means round rectangular represent the system state. Okay, next they may include brief description following do of the action taken in the in that state. The labeled arrow represents the stimulus that force a transaction from one state to another state. Means event. It should be occur means it should move from one state to another state. Okay, waiting. Full power means it's going to get the arrow from this to this one state ಇಂದ ಇನ್ನೊಂದು ಸ್ಟೇಟಿಗೆ ಲೇಬರ್ಡ್ ಆರೋ ಇದ್ದರೆ ದಟ್ ಈಸ್ ಟ್ರಾನ್ಸಾಕ್ಷನ್. ಓಕೆ, a UML notation let you indicate the activity that take place in the state. In a detailed system specification, you have to provide more detail about the board simulation and the system state. Here I told that this rectangular boxes represent the state, and this named arrows means off, full power, off power, and timer, door open, door close, start, cancel. These are the some of the simulation, and this round filled circle is the start of the process. This is circle inside the circle is end of the process. Okay, here state. What are the states? First one is wait. What is the description? A O1 is waiting for input. The display shows the current time. Okay, here this is the state diagram of micro oven system. Okay, this is the state diagram of micro oven system. Okay, in this micro oven system, state diagram of micro oven system, there is a sum of the status. First one is waiting. What is this waiting state? Indicates a oven is waiting for input. The display shows the current time. Off power, the oven power is set to 300 watts. The display show off power means if it is set to 300 watts means it is a off power. What is mean by full power? 600 ವ್ಯಾಟ್ಗೆ ಸೆಟ್ ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ ಫುಲ್ ಪವರ್. ಸೆಟ್ ಟೈಮ್ ಅಂದರೆ ಕುಕ್ಕಿಂಗ್ ಟೈಮ್ ಇಸ್ ಸೆಟ್ ಟು ದಿ ಯೂಸರ್ ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ. ದಿ ಡಿಸ್ಪ್ಲೇ ಶೋ ಕುಕ್ಕಿಂಗ್ ಟೈಮ್ ಸೆಲೆಕ್ಟೆಡ್ ಈಸ್ ಅಪ್ಡೇಟೆಡ್ ಆಸ್ ಇಸ್ ಟೈಮ್ ಇಸ್ ಸೆಟ್. ಮೀನ್ಸ್ ಒಂದು ಟೈಮ್ನ ಸೆಟ್ ಮಾಡ್ತೀವಿ ಕುಕ್ಕಿಂಗ್ ಟೈಮ್ಗೆ, ಅದು ಮ್ಯಾನ್ಯುಯಲ್ ಆಗಿ. ಮೀನ್ಸ್ ಯೂಸರ್ set time is you are going to call it as set time. Disable means oven operation is disabled for safety. Okay, interior oven light is on, display show not ready. Means first you are going to check the oven is ready or not. If inside light is on means ಡಿಸ್ಪ್ಲೇ ಶೋ ನಾಟ್ ರೆಡಿ ಅಂತ. ಅನೇಬಲ್ ಅಂದರೆ ಓವನ್ ಆಪ್ರೇಷನ್ ಇಸ್ ಅನೇಬಲ್, ಇಂಟೀರಿಯರ್ ಓವನ್ ಲೈಟ್ ಇಸ್ ಆಫ್, ಡಿಸ್ಪ್ಲೇ ಶೋ ರೆಡಿ ಟು ಕುಕ್. ಆನ್ ಇದ್ದಾಗ ಇಂಟೀರಿಯರ್ ಲೈಟು ಇಟ್ ಈಸ್ ನಾಟ್ ರೆಡಿ ಫಾರ್ ಕುಕ್ಕಿಂಗ್. ವೆನ್ ಇಂಟೀರಿಯರ್ ಲೈಟ್ ಆಫ್ ಓವನ್ ಈಸ್ ಆಫ್ ಮೀನ್ಸ್ ಇಟ್ ರೆಡಿ ಟು ಕುಕ್. ಆಪ್ರೇಷನ್, ವಾಟ್ ಆಪ್ರೇಷನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕನ್? Oven is operation, interior oven light is on, display shows the interior countdown, and completion of cooking, the buzzer is sounded for 5 seconds, oven light is on, display show cooking complete while buzzer is sounding. Okay, means what is the process you are going to occur, that is explained in the description. Okay, next there are some of simulation. Okay, which are the simulation? Full power, off power, timer, door open, door close, start, cancel, number. These are the some of the simulation. Off power, the user has pressed the off power button, nothing but 300 watt button is pressed. Full power means user pressed 600 watt button. Okay, timer, user has pressed one of the timer button means one time na set ಮಾಡ್ತಾನೆ, that is depend on user. Number, the user has pressed a numeric key. Door open means the oven door switch is not closed. Okay, door closed, the oven door switch is closed. Start, the user has pressed the start button for the starting of the cooking. Cancel, the user presses the cancel button. Okay, these are the simulation. Okay, the problem with this state based modeling is that the number of possible state increases rapidly. What is the disadvantage of this state diagram? In state diagram, there is a number of state will be increased rapidly, means there is no boundary for the increase of states, means it going to increase the possible state rapidly. Okay, for large system model, therefore you need to handle detail in the model, means if there is a large system, if rapidly increase the state means it is very difficult to handle. So one way to do this is by using the notation of separate superstate that encapsulate a number of separate states. This superstate look like a single state on a high level modeling, but it is then expanded to show more detail on separate diagram. Means superstate use ಮಾಡಿಬಿಟ್ಟು we can reduce or we can keep all the states in one separate diagram like this. Okay, operations, cooking. Okay, do check status. Okay, run generator. Okay, turntable fault, emitter fault. Okay, if it is there is a fault, there should be a display event, that is alarm. Alarm should be on when there is a fault. Okay na. Next, after timeout, the buzzer should be on for 5 seconds. Okay, door open means any fault we should disable, means door should be open. Okay, next cancel, and we should wait for the next process. Okay, this is how we are going to use this event driven modeling. Okay, they told here one way to do this means in state diagram there is a chance of increasing the status randomly. So what we can do here we use the notation of superstate that encapsulate a number of separate state. Means here we should do one superstate that going to collect number of separate state. Okay, what this superstate will do, this superstate look like a single state on a high level model, but in the expanded to show more detail on separate diagram. Okay, here in this diagram, operation is the super state where look cooking checking, cook, alarm, done. These are the sub status. Okay, sub status. Okay, like this we are going to use this state diagram. We are going to reduce to super state. This super state look like a single state on a high level model, but is then expand to show more detail on a separate diagram. Okay, thank you. This is the end of 4 models. One is context, second one is interaction, third one is structural, fourth one is behavioral. If they are going to ask like this, explain the all system models, means you have to explain these 4: context, interaction, structural and behavioral. These 4 models should be explained. When they are asked about explain in detail system models, means you have to explain these 4 models. Okay, next class I am going to explain model driven engineering. What is meant by model driven engineer? What is the use? We are going to discuss in the next class. Okay, thank you. I am going to end this session here.